this video, I am going to explain about worksheet questions of group 13. Group 13 is also known as third year group elements. We will discuss one by one. So very important question. BH2O 6 times 3 plus and yet BOH 4 times minus. Two complexes are given. So in first complex, see BH2O 6 times 3 plus and the second complex BOH 4 times minus is given. So clearly in this covalency of boron is 6. So in this complex covalency is of boron is 4. So we know valence shell of boron contains 4 orbitals only. Therefore covalency of boron can be only 4 but not 6. That means so assertion is wrong. So boron can form maximum of 4 bonds. It is unable to form 6 bonds due to absence of d orbitals in valence shell. Therefore A's assertion is wrong. So being electron deficient, boron readily reacts with Lewis bases like H2O and OH minus. So boron has one vacant orbital in its valence shell. Therefore, it can accept a pair from Lewis bases. So reason is correct. Therefore, option D. Next. The correct order of Lewis acidic nature of boron trihalides. Boron trihalides is. So here it is given BF3, BCl3, BBr3 and BI3. So first I am taking BF3. I am taking first and last compounds BF3 and BI3. So both are planar structures. Here fluorine 3 lone pairs. Similarly iodine also 3 lone pairs. Next at boron one vacant orbital will be there. Here also one vacant orbital. So here lone pair is present on 2p. Here boron also 2p. So there is maximum overlapping. Maximum overlapping between B and F. This will be known as back bonding. So maximum back bonding is possible in BF3. So while in case of iodine, lone pair is present in 5p orbital and boron has 2p. So there is minimum overlapping. Minimum overlapping between B and I. So here back bonding is not possible. So due to back bonding, the vacant orbital in boron is filled with electrons. Therefore, it cannot accept electron pair from Lewis base. Therefore, Lewis acidic nature decreases. Here Lewis acidic nature increases. Therefore, order will be first BI3, next BBr3, BCl3 and BF3. This is Lewis acidic nature. So option C. So due to back bonding in BF3, boron cannot accept electron pair from Lewis space. Therefore, Lewis acidic nature decreases minimum. Lewis acidic nature is maximum in Bi3 due to vacancy. Next, important. Aluminium when reacted with aqueous NaOH liberated a gaseous molecule. Majorly the gas is. Here, aluminium reacts with NaOH, aqueous NaOH, Al plus NaOH plus H2O. We get compound like this: 2Na Al OH 4 times. This will be in the form of complex plus 3H2. Here we are balancing 2Al, 2NaOH and here 6H2O. So this is the complex formed. Sodium meta-aluminate complex. Or we can write sodium tetrahydroxoaluminate. Oxidation state is 3. So H2 gas is released. Therefore option A. This is the reaction between aluminium and aqueous. This is aqueous NaOH. H2 gas will be released. Next. A simple question only. So H3BO3, AlCl3, B3N3H6 and BF3. So first I am writing A option. H3BO3 is polymeric due to hydrogen bonding. So hydrogen bonding is present. That's why it is polymeric. Next option B. So option B is AlCl3. AlCl3 can form dimer. That is Al2Cl6. So in this way it can form Al, here Cl. Like this it can form. Here one day2 bond, here one day2 bond, dimer. Next C option B3N3H6. This is inorganic benzene or borazole or borazine. Next D. BF3. In BF3, now only we have discussed back bonding is present. Back bonding is maximum in case of BF3 due to 2p effective overlapping. So here option A, H3BO3 hydrogen bonding, A3. Next B, AlCl3 dimer, B1. C, B3N3H6 inorganic benzene, that is C4. D, BF3 back bonding, C2. So therefore option D, A3, B1, C4, D2. When orthoboric acid is subjected to strong heating, the residue left is. So orthoboric acid means H3BO3, or we can write it as BOH thrice. So which on strong heating it can release first HbO2 metaboric acid. This is orthoboric acid. and this one metaboric acid, which on again strong heating, red heat, it gives B2O3, boric anhydride. So final compound is B2O3, boric anhydride or boron trioxide. Option C. Next, H3BO3 is. So H3BO3 can be written as BOH thrice. It can react with water, that is H plus and OH minus. So here boron has one vacant orbital that can accept OH minus. So since it is accepting OH minus, it is Lewis acid, that acts as Lewis acid, and it gives BOH 4 times with minus plus H plus. So due to release of H plus ion from water, it acts as weak acid, weak Lewis acid. Since it is producing 1 H plus, one molecule of orthoboric acid is producing one molecule, that means 1 H plus ion, it is monobasic. Therefore, H3BO3 is monobasic. So due to release of 1 H plus ion by one molecule, 1 H plus ion, and weak Lewis acid. So because it is accepting OH minus from water, from H2O. So therefore option A, monobasic acid, and it is weak Lewis acid. So Lewis acidic nature is due to acceptance of one pair of electrons. It is accepting one pair of electrons from OH minus. Monobasic means it is releasing one H plus ion from water. It is indirect acid, not protonic acid. Next, the oxidation state N, coordination number of aluminium, oxidation state, coordination number, and the number of valence electrons around aluminium in Al2Cl6 are respectively. So very important. Al2Cl6 means, you can write, which is dimer. This is dimer of AlCl3. Here you can calculate oxidation state. So Al2Cl6, aluminium say X plus 6 into minus 1 equal to 0. So that implies X equal to plus 3. Oxidation state 3. Next, coordination number means, so number of oppositely charged, that means number of nearest atoms simply. Number of nearest atoms around aluminium 4. 4 Cl atoms are arranged. Therefore, coordination number 4 due to 4 chlorines. 4 Cl atoms. Next, so valence electrons around aluminium. So valence electrons equal to how many bonds total around aluminium? 4 bonds. Therefore, 8 electrons. So therefore option B, oxidation state 3, coordination number 4, and valence electrons due to 4 bonds 8. Next. So bonding in diborane can be described by. So diborane structure will be like this. So very important. one hydrogen above the plane and one hydrogen below the plane. So each boron undergoes sp3 hybridization. So two types of bonds present. First, here two centered two electron bond. This is also two centered two electron bond. Two centered two electron bond. Two centered two electron bond. So but BHB bond is three centered two electron bond. This is also three centered two electron bond. That means two centered two electron bonds equal to 4 and three centered two electron bonds equal to 2. 4 and 2. Therefore option A. Next. So very important. Which are the following elements does not form triiodide on reacting with iodine? Triiodide. See here. Boron, aluminium, gallium, indium, thallium. See from boron to thallium, plus one state increases due to inert pair effect. Inert pair effect. So for thallium, plus one oxidation state is highly stable. Therefore, it can form only TLI will be formed. And TLI3, so TLI means here plus 1 minus 1 and here plus 1, this is minus 1, that is plus 3. In second case, plus 3. So for TL plus 3 is unstable, will not be formed. That is based on inert pair effect. So plus 1 is stable. Therefore, it can form only monoiodide. Triiodide will not be formed. Therefore, option B. Next, in this direction also remember plus 3 oxidation state increases. Bottom to top plus 3, top to bottom plus 1. Next. So borax dissolves in water and forms a product of boron. Identify the compound. Borax. Na2 B4O7 reacts with water to form H3BO3, boric acid and NaOH. So NaOH we know sodium hydroxide, and this one orthoboric acid. So which will be formed? Which will be formed is H3BO3 is there in options. Therefore option D. So this solution becomes this weak acid and it is strong base. Therefore solution will be alkaline. It can form alkaline solution due to strong basic nature of NaOH. So option D, H3BO3 weak acid. Next. Identify correct statements about anomalous behavior of boron. So boron trihalides can form dimeric structure. They cannot form dimeric structure. So dimeric structure will be formed by those elements which are having vacant d orbitals in their valence shell. Therefore, statement 1 Wrong. Next, boron shows +1 as stable oxidation state. That is also wrong. So boron can show -3 or +3 oxidation states. Next, 3. Maximum covalency of boron is 4. That is correct. So due to 4 valence orbitals. So boron has 2s and 2p subshell. 2s means 1 orbital, 2p 3 orbitals. So by using 4 orbitals, it can form maximum of 4 bonds. Therefore, next, boron does not form BF6 3 minus ion. BF6 3 minus not possible. So maximum covalency of boron is 4. It cannot form 6 bonds. So due to absence of d orbitals. Remember these three. So correct options are 3 and 4 only. 3 and 4, option C. Next, consider the following reaction. BCl3 NH3 gives BCl3 dot NH3. The geometries of BCl3 and BCl3 dot NH3 respectively are, we can write like this. So first take BCl3. So I will write first NH3. After that BCl3. NH3 can be written as like this. It is having one pair plus BCl3 has one vacant orbital. So this acts as Lewis base and this one Lewis acid. Therefore, it can donate one pair to BCl3. It forms NH3 BCl3 adduct. Adduct means here addition compound. So before bond formation, I will add here hybridizations. So nitrogen sp3, BCl3 sp2, and here sp3 no change, and here sp3. Check here. We'll add geometries also. The geometry is very important. Here pyramidal. NH3 pyramidal. Next BCl3 planar. Next here both are tetrahedral. Now check here. So before bond formation planar, after bond formation tetrahedral. That is option A. Very important. Addition compound, Lewis base and Lewis acid reaction. Next. Which of the following compounds are formed when boron trichloride is treated with water? Simple question. Boron trichloride means BCl3 treated with water. It gives direct NCERT question. H3BO3 plus HCl. So balance this one. Write 3H2O, 3HCl. So this one boric acid and hydrochloric acid. Check here H3BO3 and HCl will be formed. Option A. Next. Acidity of BF3 can be explained on the basis of which of the following concepts? So BF3 has one vacant orbital. Vacant orbital. Therefore, it can accept a pair of electrons from Lewis base. Therefore, it acts as Lewis acid. That means electron pair acceptor. Electron pair acceptor is Lewis acid. Due to the presence of vacant orbital, it acts as Lewis acid. Therefore, basing on Lewis concept, you can explain acidic nature of BF3. Next. So what is X in the following reaction? NaH, sodium hydride reacts with diborane. Check here first. NaH, sodium hydride reacts with B2H6 diborane in ether. So here ether is solvent. Now solvent stabilizes B2H6. So it gives Na, one second, Na BH4 complex type. So balancing 2 NaH plus B2H6 gives 2 moles of NaBH4. So here this compound will be ionic in nature, Na plus and BH4 minus, NaBH4. So which is sodium borohydride. Sodium borohydride, SBH. It is powerful reducing agent. For option A. Next. Which are the following metals exist in liquid state during summer season? So physical state can be decided by melting point. So melting point of gallium is approximately 29 degrees. 29 degrees centigrade. So summer temperature will be more than 29 degrees centigrade. Therefore, gallium is also known as summer liquid due to its low melting point. 29.76 will be there. Approximately I am taking 29 degrees. So gallium is summer liquid. So due to low melting point. Next. In which of the following reactions hydrogen is liberated? Take your first reaction. Aluminium plus HCl. So it gives AlCl3 plus H2 gas. Balancing will get 2Al plus 6HCl gives 2AlCl3 plus 3H2. Hydrogen gas will be released. Next, Al plus NaOH. So 2Al plus, so 2NaOH gives 2NaAlOH 4 times plus 3H2. Here also hydrogen gas will be released. Next, third is very important. NaBH4 sodium borohydride plus I2 gives 2 moles of BH3 plus 2 moles of NaI plus H2. Here this can be written as B2H6 diborane preparation. Diborane preparation. So this reaction can be also written as one more form of this reaction. Second reaction, or Al plus NaOH gives NaAlO2 plus H2. In this way also we can write H2 gas will be the sodium meta-aluminate. Here H2O will be there. After getting H2O, so total number of hydrogens 3 into 2 6 plus 4 into 2 8. 14. 14 means here 6H2O should be there. OH 4 times. Okay, next. So here options 1, 2, 3 all are producing H2 gas. Next. The correct statement is Bi3 is weakest Lewis acid. We know Lewis acidic nature. Bi3, BBr3, BCl3, BF3. So therefore A is incorrect. Next, B. There is minimum p-pi back bonding in BF3. So there is maximum p-pi overlapping or back bonding because of 2p overlapping. So 2p overlapping is maximum in BF3. Next, C. BF3 is strongest Lewis acid among boron halides. Bi3 is highest. Same explanation. BBr3, BCl3, BF3. Bi3 is strongest Lewis acid. And D. So there is maximum p-pi bonding in BF3. Maximum p-pi back bonding. So these are reasons. Now we can check. So there is maximum p-pi back bonding in BF3. That is only correct. Remaining all are wrong. So this is Lewis acidic nature. So very important. So here Bi3 maximum, BF3 maximum is given. Therefore C also wrong. Next. The complex formed when Al2O3 is leached with bauxite using concentrated NaOH. This is Bayer's process. Bayer's process, which is leaching of Al2O3, which is bauxite, white bauxite. So here reaction will be Al2O3, so which is bauxite ore 2NaOH plus 3H2O gives 2NaAlOH 4 times. So this will be commonly known as sodium meta-aluminate. Very important. Option A. This is completely soluble. This one bauxite ore. So bauxite ore when treated with aqueous solution of NaOH, it forms soluble complex sodium meta-aluminate. It is Bayer's process for leaching of bauxite ore. Next, dry ice is solid carbon dioxide. Solid carbon dioxide is dry ice. It can be used for refrigeration purposes. Refrigeration. So due to very low temperature. So clearly option C. Simple question only. Or common name for solid CO2 is dry ice or dry cold. Dry cold. Next. So what is X in the following reaction? Al plus NaOH plus H2O gives. Simply, this is a repeated question. 2Al plus 2NaOH plus 6H2O gives 2NaAlOH 4 times plus 3 moles of H2 gas. So this can be written as Na plus and AlOH 4 times minus sodium meta-aluminate. Sodium meta-aluminate. Aluminate. So this is completely soluble compound. Very, very important. Repeating question in competitive exams. Next one. So diborane reacts independently with O2 and H2O to produce respectively. So diborane B2H6 reacts with O2 to form B2O3 plus 3H2O. So here make it 3O2. So B2O3 will be formed. Next B2H6 again reacts with H2O to produce, take here 6H2O, H3BO3, 2 moles plus 6H2 gas, H3BO3. So when B2H6 reacts with O2 and H2 independently, B2O3 and H3BO3 will be formed. Option A. So these are chemical properties of diborane. Next. Which of the following element has highest ionization enthalpy? So remember like this ionization: boron, aluminium, gallium, indium, thallium. Remember like this. So here greater than, less than, greater than, less than. Remember like this. Ionization energy order. Or we can write like this. B, T, G, A, I. Remember like this. B means boron, thallium, gallium, aluminium and indium like this. BTGAI. This is the order. So therefore boron has highest. After that thallium, next gallium, next aluminium, last indium. Ionization energy order very, very important. Greater than, less than, greater than, less than. Next. Borazine, also known as inorganic benzene, that can be prepared by reaction of 3 equivalents of X with 6 equivalents of Y, XY respectively are. So 3 equivalents of B2H6 reacts with 6 equivalents of NH3. It forms 3 moles of BH2, NH2 twice plus BH4 minus. So this on heating decomposes to 2 moles of B3, N3, H6 plus 12H2. So here X with 3 equivalents of X. So here this is X and 6 equivalents of Y. This is Y. Therefore B2H6 and NH3, option B. This is nothing but preparation of inorganic benzene or borazole or borazine or inorganic benzene. Remember these names. Next. So aqueous solution of which of the following boron compounds will be strongly basic in nature? So we must find what are the compounds formed. A repeated question, a similar question. Na2B4O7 reacts with water, which is aqueous solution, that gives H3BO3 plus NaOH. Next, this is weak acid, boric acid, and this will be strong base. So strongly basic means due to NaOH, strongly basic. Therefore, option D. So this one, borax. Borax on reaction with water can produce weak acid and strong base. Therefore, solution will be strongly basic or alkaline in nature. Therefore, option D. Next one. This is very, very important. So what are the assertion? Boron is unable to form BF6 3-, which is correct. BF6 3- not possible due to absence of d orbitals in boron. Boron has only s and p orbitals. Therefore, it cannot expand its valency up to 6. Therefore, not possible. Assertion correct. Next, size of B is very small. So, very small. In group, atomic radius increases. B small in size. So, down the group, atomic radius increases, we know. So, both are correct, but reason is not correct explanation. Therefore, option B. So, this is also correct. It is very small. Next one. Maximum number of hydrogen atoms present in the same plane in diborane molecule. So, diborane structure. Here BH2 and here BH2 and here two hydrogens, bridging hydrogens. One is above the plane and the other one below the plane. Above the plane, below the plane. So here this part, this BH2 part. This BH2 part. This BH2 lies in same plane. That means total 6 atoms lie in same plane. But here asking about hydrogen atoms. Totally 4 hydrogen atoms. Terminal hydrogens. These are terminal and these two are bridging. 4 terminal hydrogens lie in same plane. Therefore, option B. So total 4 hydrogens lie in same plane. So bridging hydrogens in different planes. Next. So diborane reacts independently with O2 and H2O to produce respectively. Here simply B2H6 reacts with O2 to form B2O3 plus H2O. So balance this reaction. Here 3O2, here 3H2O, B2O3 boric anhydride. Boric anhydride. Next B2H6 again reacts with water to produce. So balance this 6 H3BO3 plus 6H2 2H3BO3. Orthoboric acid. These two compounds will be formed B2O3 H3BO3. Option A. Chemical properties of diborane. This is diborane. So with oxygen it can form oxide. With water it can form acid. Next. The relative stability of +1 oxidation state. Simple question. Boron, aluminium, gallium, indium, thallium. Say all are +3. Here also 3 plus. This will be the stability order. If all are +1, this will be the stability order. Very, very important. That means aluminium, gallium, indium, thallium. Therefore, option D. Due to cannot pair effect. Cannot pair effect. Next. The number of 2-centered 2-electron, 3-centered 2-electron bonds in B2H6. So based on structure we can say similar question completed already. Similar question. Write structure like this. Above the plane, bridging hydrogen, one above and one below. So terminal hydrogens, bridging hydrogens. So here types of bonds, 3-centered 2-electron bond. Here also 3-centered 2-electron bond. Remaining all are 2-centered 2-electron, 2-centered 2-electron, 2-centered 2-electron. Here also 2-centered 2-electron. So total 2-centered 2-electron bonds equal to 4 and 3-centered 2-electron bonds equal to 2. So option B. This model is very, very important. In any way they can ask questions. Number or structure they can ask. So this bond is also known as banana bond or tau bond. Important. Next, it is the end of the chapter. In next video, I will explain one more chapter. All the best and thank you.